A couple videos ago, we looked at the charts of key values for the sine and cosine functions. These charts give us the primary features that are helpful for graphing them. The x-coordinates correspond to the maximum and minimum values as well as the x-intercepts. When these functions are transformed, it turns out that we can graph them by simply focusing on the key values. Here is the process. Step 1. Identify the fundamental period. Step 2. Use the fundamental period to identify the x-coordinates of the key values. Step 3. Transform the corresponding y-coordinates. Step 4. Plot the points and sketch the graph. We will work through these steps using an example. Example. Graph y equals -2 sine of 2x minus pi over 2 plus 3. We discussed steps 1 and 2 in the previous video. As a reminder, to get the fundamental period, you must set the argument equal to 0 and 2 pi, and then solve for the variable. This gives us x equals pi over 4 and 5 pi over 4. We then break the fundamental period into 4 equal parts by finding the midpoint of the fundamental period, and then the midpoints of the two intervals that we just created. The midpoint between pi over 4 and 5 pi over 4 is 3 pi over 4. The midpoint of the left interval is 2 pi over 4, or pi over 2, and the midpoint of the right interval is 4 pi over 4, or just pi. These 5 values become the new x-coordinates of the key values. Transforming the y-coordinates is a matter of simply plugging in values. Technically, you are substituting in the values x1 through x5, but there's a shortcut that we can use. When you plug in the key values, the sine and cosine functions evaluate to -1, 0, or 1, corresponding to the base function. So to transform the y-coordinates, we replace the entire sine or cosine function with the appropriate value, and then perform a short calculation. For the first key value, the location is the midline, so the sine function evaluates to 0. And when we replace the entire sine term with 0, we get 3. This means that the y-coordinate for the first key value in the transformed function is 3. For the second key value, the sine term is 1, corresponding to the peak. And when we make the substitution and evaluate the value, we get 1. We can continue this process for the rest of the values and plug these numbers into the chart. Lastly, we plot the points and sketch the graph. When setting up the graph, it is important that the axes are chosen well. We want to pick a spacing in both directions that makes sense for the points that we need to graph. In this case, we have an x spacing of pi over 4 that we will need to work with, so we will make sure our graph is set up that way. For the y direction, we can make each step 1 unit. And now we can plot the points. It is useful to draw the midline at this time for visualization purposes. These points help us to graph the curve in the fundamental period, but since the function is periodic, we can extend the pattern. This will give us the shape of the graph beyond the fundamental period. We will work through a couple more examples in the next video, and then we will work with the general theory of transformations for a bit.